Okay. You can see the screen.
Yes, sir.
Okay, the quadratic equation is part of this complex numbers chapter.
Yeah.
Okay, and there are questions coming from this in advanced and all. So I thought I'll do it some extent. Okay. Okay, the general form of quadratic equation is ax square plus bx plus c, right?
Yeah.
And what are ABC?
Coefficients.
Yeah, real numbers.
Yeah.
Okay, and how do the graph of this thing looks? Y equal to, if I take this as y, yeah, that is one. And any other possibility? Okay, then okay, this is the x-axis. The equation of x-axis y equal to 0. Okay, so these are the different possibilities. One, it can be like this, or it can be like this. Or it can be like this, or it can be like this. Four possibilities. So this is a greater than 0. This is also a greater than 0. And this is a negative. And this also a negative. So what are the difference between these two? The first two?
Sir, first one has no real roots, and second one has two real roots.
Yeah, so this is discriminant is negative.
Yeah.
Here discriminant is positive. Here discriminant is positive. Here discriminant is negative. And discriminant is b square minus 4ac. Right, there is one more possibility. The curve can be like this. Okay, or like this. Just touching the x-axis. So here, what is the condition?
D is equal to 0.
So both roots will become equal. Okay, so these are the only possibilities. It's either u or inverted u. Okay. Okay. We have this formula for the roots, right? Minus b plus or minus square root of discriminant divided by 2a.
Yeah.
How do you get this formula?
Sir,
Once you should know how to get it. It's ax square plus bx plus c equal to 0, right?
yeah.
So take a outside. b by ax plus c by a equal to 0. And this you can rewrite as x plus b by 2a whole square. Okay, this will give me x square. And then 2 times ab will give me this term. Okay, and then I'll get an additional term that I have to subtract. So b square divided by 4x I have to subtract. Okay, and then plus c by a. Is that right? Getting it? This thing I'm rewriting like this. This is called method of completing squares. Okay, so this thing I'm adding a sum square minus some remainder. Okay, so this thing is if I'll get the x square term. Okay, and then I'll get the x term as 2 times a into b. Okay, that is 2 times x into b by 2a. So I put a 2 here. Okay, so that I'll get this x term. And after that, I'll get the constant term which has to be subtracted. Is it clear? So from this you'll get this square equal to e square divided by 4a square minus c square. Now we can take the square root. So this thing will become square root of this right hand side. So from that I can get x as minus b by 2a. So once you take the square root, you'll get plus or minus square root of this thing. So that if you simplify, you will get this one.
Yeah.
Okay, so this is called method of completing squares. For example, if you have to represent this number 50 by squares, so how will you write 50?
2 into 5 square.
It's 49 plus 1 and 49 is 7 square plus 1.
Okay.
Okay. So this is a similar idea here. Whatever is the thing I'm writing is in terms of squares.
Okay.
Okay, this way we get this formula. Okay, this is fine. You know this thing, discriminant. Right. These things are basically already might be knowing. Sum of roots is minus b by a, and product of root is c by a. These two you know, right?
Yeah.
And then you can see difference between the roots is square root of the discriminant divided by a. Okay,
Yeah.
right. So one more thing. Suppose you have a quadratic equation with roots alpha and beta. How many quadratic equations can have the same root? So this is the x-axis. I have two roots alpha and beta. So how many parabolas can have these two roots? 1, 2, 3. So one parabola is like this, right? Okay. Another parabola is like this. Any other parabola which will have the roots as alpha and beta. And beta. Then how many parabolas can be there?
So infinite.
Yeah, I have drawn true. So
Yeah.
what are the other parabolas? It can be also like
Sorry,
this.
sir.
I have drawn two parabolas,
Yeah.
U and inverted U. So what are the other parabolas? It can be like this, no?
Their curvature will be different.
Yeah. So what is the difference between these two? A will be different. A1, this will be A2. Because the parabola roots are alpha and beta means it will be like this. X minus alpha and x minus beta. And I have an A here. This value of A I can change. And the roots still will be alpha and beta. Okay. So depending on different values of alpha, I'll get different parabolas. Okay. Right. So this is a JEE advanced question 2016. Can you just try this one? You know how to solve it?
Yes, yes, sir. I'm just trying to.
Okay, so you have to find alpha 1 and beta 1. Similarly, you have to find alpha 2 and beta 2. Okay, it's a little bit lengthy problem.
Okay, sir. I understood.
See, and the angle they have given us minus pi by 6 to minus pi by 12, right? Pi by 6 is 30 degrees, and this is 15 degrees, half of it. Okay, so this is the fourth quadrant, the angle. Theta is in the fourth quadrant. In the fourth quadrant, cos is positive, and then secant is positive, right?
Okay.
Other things are negative. So tan is negative in the fourth quadrant. So if you take the negative sign, alpha 1 will be less than beta 1 because tan is negative, and they have given that the higher root is alpha. Okay, so when you take the negative sign, you'll get alpha. When you take the positive sign, you'll get beta 1. Okay, so that's why I've taken the positive sign for beta 1 and negative sign for alpha 1. Okay, similarly, you have to find alpha 2 and beta 2. Is this correct? Alpha 2 minus beta 2 is alpha 1 plus alpha 2 whole square, that is 4t square minus 2 alpha 2 beta 2, that is, okay, so this is 4t square plus 2, right? this will be plus 4. So this will be 4 times secant square, right? So alpha 2 minus beta 2 is plus or minus 2 secant. So from this I'll get alpha 2 as 2 alpha 2 is minus 2t plus or minus 2 secant. So alpha 2 is minus t plus or minus secant, and secant is positive, right? So I have to take the alpha is greater. So I have to take positive sign here. Okay. So beta 2 will become minus t minus secant. Okay. And you have to find alpha 1 plus beta 2. Alpha 1 is secant minus tan. And then beta 2 is minus t minus secant. So secant will cancel. So the answer is minus 2 tan. So C is the answer. Okay. So one important thing to realize where the angle is in the fourth quadrant. In the fourth quadrant, cos and secant are positive. Okay. And then you have to find the roots alpha 1 and beta 1 by using this alpha 1 minus beta 1 whole square equal to a plus b whole square minus 4ab. So we'll get the roots alpha 1 beta 2, beta 1. And then it's given alpha 1 is greater than beta 1. So from that you have to decide which is alpha 1, which is beta 1. Right? Lengthy problem, but simple problem. Is it clear? Okay.
Yeah.
Okay. Try this one. Beta and alpha beta are known, right?
Yeah.
So alpha plus beta is 3 by 3. And alpha beta is 5. Then the equation whose roots are let me call this root 1, root 2. So I have to find R1 plus R2 and then R1, R2. If I find this thing, I can find the equation, right? Is that clear?
Yes, sir.
Equation whose roots are R1 and R2. So I have to find R1, R2, R1 plus R2 and R1, R2. So this I can simplify. Alpha square plus beta square minus 3 times alpha plus beta plus 2 times 7. Right? Alpha square plus beta square write as alpha plus beta whole square minus 4 alpha beta. Okay, so R1 plus R2 is known then. Okay, just see the method. Is it clear? R1 plus R2 is known. This is alpha square. Okay, I'll get alpha square, beta square, and then minus 3 alpha beta into alpha plus beta. Right? And then constant 49. 3 into 3, 9 terms, right? 1, 2, 3. Okay, and then I'll get alpha square and then beta square. Alpha square beta square and then alpha square beta. Okay, 1, 4, 4 plus 2, 6. Is there anything else I'm missing here? R1, R2, alpha square, beta square, and then 7 alpha square, and then alpha beta square. Oh, alpha beta. Alpha beta term will come, right? And then alpha term will come, beta term will come. So it will come out as some. So everything is known in R1, R2. Right? Alpha square.
Yes,
beta,
yes.
so even R1, R2 is known.
Yeah.
So once these two are known, I can find the answer. Again, calculation is lengthy. Oh yes. Okay. There is another simple way of doing it. See, the alpha and beta roots of this equation, right?
Yeah.
From that, you will get these two conditions.
Yeah.
Okay, so from that, I can write alpha square minus 3 alpha as minus 5.
Yeah.
So this is plus 2 then. This first root.
Yeah. Yeah.
Okay, similarly, the second root is similar thing. Okay, so the roots are 2 and 2. Yeah, you have to use this trick. Once we know something is a root of this one, then we can combine alpha square and alpha as something simpler if it's matching with this equation. Okay,
Okay.
this is the correct way to do it. Fine. What about this one? Alpha and beta roots of this one in the value of G alpha plus B. Okay, so again we have the condition for alpha plus beta. It's minus B by A, and then alpha beta is C by A. And you also have this thing E alpha square B alpha plus C equal to 0, and then A beta square plus B beta plus C equal to 0. So in the calculation, if you have this sort of a combination, I can reduce it by using C. Getting it, no? By
Yes.
calculating, if I get this combination of A beta square plus B beta, I can reduce it to putting it as minus C. So that's why we can use these two. So this value of that is 1 by A alpha plus B whole square plus 1 by A beta plus whole square. Right, so if you square it, you'll get A square alpha square. Okay, find the value of that thing, right? So we take the LCM. And then, A alpha plus B, right.
We don't
Yeah,
need to calculate.
yeah. From this, you get A alpha plus B as minus C divided by alpha.
By
Yeah, that is
yeah.
that's the way to do it. So reciprocal, square it, you get alpha square by C square, and this thing will become beta square by C square.
So
So it's alpha square plus beta square.
by C square
That is alpha plus beta whole square.
minus 2 alpha beta.
4 times. A minus B, A square plus B square is A plus B whole square. Sorry.
Minus 2 AB, right, sir?
Two, right?
Yes, sir, I think it will be 2.
Okay. So this is b square minus 2ac by a square c. Is that right?
Yes, sir.
B square minus 2ac divided by a square c square. A square. This is c square.
Okay, sir.
Yeah, this is the key step. You have to use this one, otherwise it will be difficult. The A for which the quadratic equation has integral roots. Integral means it's an integer value.
Yeah.
Okay, so this is I think you can open it. X square minus
A plus 10A.
and then plus 10a plus 1 equal to 0. Okay, so this is basically the parabola in this form. Okay, first condition is the discriminant has to be greater than 0 for it to have roots, right?
Yeah.
And then the roots will be minus b plus or minus square root of d divided by 2a. So for it to be integer, first of all, this has to be a perfect square. D should be a perfect square. Otherwise, it will not be an integer, right? B is an integer. Is B an integer? Yeah, A is an integer. A is an integer. Okay, so A plus 10 is B. So B is an integer. Okay, so this thing has to be a perfect square. Only then this root will be an integer. And what is discriminant? B square
Minus 4AC.
minus 4 in A plus 1 is should be greater than 0. A plus 10, right? So this is A square plus 20A plus 100 minus 48 minus 4 is greater than 0. So this is minus 20 and then 100, right? So this has to be greater than 0.
Yeah.
Okay, then this means the discriminant of this one should be negative.
Okay.
Why is it going so lengthy? Okay, discriminant is this one. Yeah, this is what we got, right? Okay, here there is a shortcut. Okay, this equation we got. The discriminant is this one. Okay, by method of completing squares, you can rewrite like this.
Okay.
Okay, and from this you can see, and we want D has to be a perfect square. No, that's what we want. D should be a perfect square. Only then the
Yeah.
roots will be integral. So for D to be a perfect square, and okay, so this thing should be, this thing is already a square. Okay, he's saying this is possible only if this thing is equal to 4. Okay, so a is an integer, no? So this thing is a perfect square. So this thing can be either 1 or 2 square is 4 or 9 or 16, like that, right? The value of this thing can be either 1, 4, 9, 16, like that, because a is an integer. Okay, so and then when I subtract 4, it should still be a perfect square. Okay, so 16 minus 4 is 12, it is not. 25 minus 4 is 21. Then 49 minus 4 is this thing. So it's not possible. Only possible values when this thing is uh, equal to 4. Only possibility is when this first term is equal to 4. Okay, then d will be equal to 0. Okay, then d is a perfect square. So the only way this can happen is d equal to 0. So when d equal to 0 means a is 10. No, d equal to 0 means this thing is 4. The square is 4. So this is a minus 10 is plus or minus 2. From that we'll get a as 12 or 8. Okay. So you have to convince that for d to be a perfect square, this thing it can be either 1, 4, 9, 16, 25, 49, like that. So only for this thing being 4, this d will be a perfect square. Otherwise, it will not. Any perfect square if you take and subtract by 4, you will not get a perfect square. Because 3, 4, 5 is a right angle triangle. 3, 4, 5 is a right angle triangle, no?
Yes, sir. Yeah, understood.
Hold on. 3, 4, 5 is a right angle triangle. So I'm subtracting 4, no? So hypotenuse square minus 4 equal to this adjacent square. Okay, for that to be possible, these are the only possibilities 3, 4, 5, or it should be 6, 8, 10, like that. But this 4 is fixed. Okay, so the only possible values, actually, it's not 4, 5 square minus 4 is 9. Okay, so when this thing is 25, okay. So this thing is actually 2 square. It's not 4. This triangle, how to get it as from 2? How to form a right angle triangle with 2 as one of the sides and D as this one. D as the other side. This is D and the other one is D, A minus 10. That's what this is. 4, actually root D. Okay, this sort of right angle triangle is not possible. Okay, convince yourself. This is possible only when this is 4. So that's why D has to be 0.
Okay.
Right, the equation has roots equal in magnitude and opposite in sign. The value of k is, I think it's trivial. Okay, you just have to write this as a quadratic equation, x square, and then x, and then constant term. equal to 0. So roots are equal, so the sum of the roots minus b by a, right? So this is equal to 0. So this coefficient, you have to put it equal to 0. Whatever is the coefficient of x. Is that clear? Then we
Yes,
got
sir.
b1 by a1. This is a1 b1x plus c1. I have to put b1 equal to 0. Okay, that's what was done. Okay, the roots of the equation are equal. Okay, then a, b, c, r, n. Can I try this one?
Okay.
Roots are equal means what is the condition?
D is equal to 0.
D, right? Discriminant should be 0. Is that right?
Yes, sir.
So what is the discriminant? B square, right?
Yeah, so C minus A whole square minus 4B minus A minus B.
So C square plus minus 2AC. So this thing will equal to 4 AB minus 2 BC. Right, AB minus 2 minus B square plus BC. Right. So this is minus 4AC. C square plus B square. B square. ABCRN. So if ABC are in AB, then what is the relation between ABC? 2B equal to A plus C, right?
Yeah.
Right. Okay. Yeah, there is one small catch. That's why in mathematics you have to practice. You have to recognize the pattern. This is A square. 4B square is 2B square, right?
Yeah.
Plus C square. And then minus sign is missing or what? Plus 2AC. So you can see the pattern, right? It is A minus 2B plus C whole square equal to 0. Is that
Yeah.
right? Okay, so from that you get 2B equal to A plus C. So that means it's in AP. Okay. So this is the important step. Okay, if the equation has more than two roots, then find lambda. Yeah, this is a new concept. So this is a quadratic equation, right? X square x and then constant term.
Yeah.
And he's saying it has got more than two roots. Is that possible?
No, sir.
Okay. So quadratic can be either this or this one. So at the maximum it can have two roots. Okay. But he's saying it has got more than two roots. That is possible if the quadratic equation is like this, lying along the x-axis. That is possible if a equal to 0, equal to b, equal to c. Is that clear?
Yeah.
Okay. So you just have to put all these three coefficients equal to 0. So that means lambda square minus 5 lambda plus 6 equal to 0, and is important because all should be satisfied. Lambda square minus 3 lambda plus 2 equal to 0, and lambda square minus 4 equal to 0. So the first one is lambda minus 3 into lambda minus 2, right? And this thing is lambda minus 2, lambda minus 1. So this is lambda plus 2 into lambda minus 2. So here lambda can be 2, here also lambda can be 2, and this also gives lambda equal to 2. Okay, so 2 is the one which is common for all the three conditions. The value of lambda is 2. Is that clear?
Yeah, sir.
Okay, so the logic is same like if you have two lines, okay, these two lines will intersect at one point, right?
Yeah.
Okay, or it will not intersect. If they are parallel lines, it will not intersect. But if he says that intersects at more than one point or infinite number of points, then the two lines are coincident.
Yeah, sir.
So it will be like y equal to 2x plus 3, and the second line will be 2y equal to 4x plus 6. Okay. Is it right? These two
Yes,
equations
sir.
are similar. Okay. So here infinite solution are possible. So similar logic here. Quadratic equation has got more than two roots, means the coefficients a, b, c will simultaneously 0. Okay. Okay. Common roots of two quadratic equations. So if you have two roots, alpha and beta, so one parabola will be like this, right? There
Yeah.
is another parabola which has got a common root with this parabola. So how can you draw that parabola? Should I draw? It can be like this, right? This is a parabola which has got a common root of alpha, right? Is it clear?
Yes, sir.
Okay. And this is another parabola which will have root as alpha. Okay. And once I have this thing, I can have variation of this, right? I can also go like this.
Mm.
So there are infinite parabolas which will have a common root with a given parabola.
Yeah.
Okay. And let the two parabolas be ax square plus bx plus c equal to 0, and then a dash b dash c dash equal to 0. Okay. And let alpha be the common root, the root which is common. So I have these two equations. Is this clear?
Yes, sir.
So from this, I can get the solution of alpha using this formula. This is called by Cramer's rule. If you don't know this, just accept this result. Okay.
Yes, sir.
Okay. So given two parabolas, I can find a common root given the condition they have a common root, I can find a common root as using this formula. Okay.
Yeah.
And I can also get the condition for the root, common root to exist by. Okay. So from Cramer's rule, you will get this one. Right now, just accept this result. Okay. And since there's a common root, by equating these two, I'll get a value of alpha, right?
Yeah.
Okay. And similarly, equating these two, I'll get alpha square. Okay. So if I get whatever alpha I'm getting here, if I square it, it should match with this alpha square here.
Okay.
Okay. The alpha I get from this is this one, A prime into this one, and alpha square into this one. So if I square this one, and then equal to whatever alpha square I get here, this is the condition, this one. This is the condition here. Okay. So the condition for a common root existing is the value of alpha I get from here, that I should square and equate it to the value of alpha square I get from here. Okay. And the two parameters have this same roots, then this is the condition. A by A prime equal to B by B prime equal to C by C prime. Because two parameters having same roots, the difference will come only in the A. This is A. So another parabola which will have the same root as alpha and beta will be some other value of A. Let me call it A prime. But the roots are same. Okay. And once I expand this thing, I'll get the coefficients of x square, x and this one. Okay.
Yeah.
Right. So from that, I'll get this condition. Basically, one parabola should be like this, which one has got A, B, C as coefficients. Another one which has got A prime, B prime, C prime has coefficients as this one. And these are the common roots. Okay. So if these coefficients are in the ratio, okay, then you have the same roots. Okay. Right. Okay. If you have two polynomials and divide them, this is like a rational number. Rational number is like you can express in terms of p by q, right? Where p and q are integers.
Yeah.
This is a rational number. Okay. Similarly, for expressions, if you can divide express as quotient of two expressions, then this is a rational expression. Okay. For example, this one f of x is this quantity. Okay. So f of x will be 0. Already the numerator is factorized. Okay. So f of x will be 0 whenever the numerator is 0. The numerator will be 0 at x equal to 1, -2, 3, and -6. Okay. So it is 1, -2, 3, and -6. Okay. And the denominator will be 0 at x equal to 0 and 7. Okay. And when the denominator becomes 0, the value of f of x will become infinite. So those values are not defined. So whenever denominator becomes 0, you don't include that value of x. So that's why you put a hole here. Okay. So this you are known as a wavy curve method, right?
Yes.
So this is the function will look. This is not difficult. This is not difficult to figure out. For x, value of large, the numerator is basically x, 4 factors, no? So it have x raised to the power 4 and a positive number. Okay. So for large value of x, the value of the phi of x will be infinite. So this is the point. Similarly, for large negative value also it's infinite. So this is the point. So the function will look like this.
Okay,
This is
sir.
and in between the roots, the value of the factors will fluctuate. So from that you can find whether it's negative or positive.
Okay. Sir, that's all.
You want to close? Okay. In maths, you have to go through this thing, and then you have to recognize the pattern of the question.
Okay.
So you have to practice, and then you have to remember what you learned.
Okay.
Okay, fine. Okay, then see you tomorrow.
Okay. You, sir. Bye.